Okay, hello, good everybody. Welcome to the channel. My name is Victor, and I'm going to be your anchor for this series. So this is the Cisco Ethical Hacker course. I'm currently working on Module 9. I want to look at reporting and communication. So reporting and communication, anytime you do ethical hacking, anytime you do pen testing is so crucial because you're going to need to tell your client what you actually did. You can't just like test the system and just disappear. No, it doesn't work that way. Somebody's going to contract you and say, please, can you help me test these systems to see, let's say, for instance, a simple case study is going to be a company just finished developing a software or finished developing a mobile app, or a company just finished setting up their network by a network security or a network engineering company. Now, somebody else is going to be called to say, okay, please, can you check the system to see if it is secured? We want to be sure that it's not vulnerable. We want to be sure that people cannot pilfer data, people cannot tamper with our data, people cannot have access when they're not supposed to have access. We want to be sure that our information is confidential, they're all confidential. We want to be sure that data needs to be available to who data needs to be available to. So all of those elements of information security, we want to see how we can ensure that they are in place. That's why you do reporting. That's why when you're done with your job, you're going to report back to your client and say, okay, I found this is secured. I found this is not secured. And these are my recommendations. Then the communication part of this project, remember in the very first module, we said that pen testing or cybersecurity tasks are actually tech projects. So if you understand tech project management, understanding why communication is coming to play, it's not going to be much of a hassle because you can't do a project without outlining how communication is to be done. So we need to say, how will communication be done? Are we going to do over email? Are we going to do over the phone? How are we going to communicate? What's going to be the frequency of the updates? Who is going to be the access point when we have issues? Why? Imagine you're trying to do a pen test for an application that you want to, maybe you're deploying that or doing that pen testing or for a bit assessment off peak periods. You're not even doing it in a peak period, but still something bad goes, something bad happens. Who do you talk to? So there must be a clear line of communication, and that must be documented even before you start, right? So these are the kind of things we're going to address in this particular module, reporting and communication. What we want to understand here is, can we compare and contrast important components of a written report? So what should you have in your written report? What are the major components? Then your findings, your recommendations, and remediations. You don't just test the system and say, I am done. No, you must tell what countermeasures they can explore. Even in some cases, part of your scope can include you fixing those issues. So if your scope involves fixing those issues, your quote or your bill at the end of the day might be also subjective, so that after your first phase, you can come back and ask, okay, look at what we found out. We're going to implement this particular software. We're going to do this particular training. We're going to make sure that you comply to this, and this is what's going to be the cost. So remediation is very key, or we're going to have some kind of new policy or procedure in place so that we don't have so and so vulnerability. Then some of the objectives is that you want to be able to recommend appropriate remediation based on the findings of a pen testing campaign. Then, of course, explain the importance of communication during the pen testing process. So very, very important. And all of the things you're going to do post-report delivery. Now, let's look at the first one. Compare and contrast important components of a written report. Most of the times, your report should be written. Now, understand that your report is not going to be for just technical guys in the office. You're going to be mostly doing an executive summary. In the lab sessions, we're going to see what a report looks like. You could say, I have finished a penetration testing report for a particular company, and you need to do an executive summary. And after the executive summary of your tasks, you want to also have a technical aspects that you're going to liaise with or discuss with the technical guys within the company. Because in most companies, you're still going to have a technical department, you're going to have a tech department, but mostly because you don't want to have bias. That's why maybe somebody externally is going to actually conduct the test. Because most of the times, if somebody internally checks those systems and do vulnerability assessment, they're going to say everything is fine because they configured it or they set up most of those things, or they brought in people that set up those things. So most of the time, they're going to say everything is fine. But if somebody comes in from outside to come and do vulnerability assessment, to come and do pen testing, to go and do a security audit, they are most likely to be objective. A clear written executive summary is important because it breaks down the technical findings into summary explanation that provides enough information that all technical levels can understand the result and see the values in the deliverable. If you do a vulnerability assessment, a security audit, a pen testing without actually doing a summary of all the things you did, you can't just send a report that is just screenshots, softwares, this one, I use this, I use this, I use this. The question is going to be, what was the import of what you did? What's the advantage? What's the importance? What can we find out from there? What do we have at stake? Right? So you need to cover technical details in the report, but you need to actually summarize. You need to make it such a way that people can actually understand. Now, note that C-level refers to upper executive. Yes, that when you see the word C-level executive, C-suite, so we just mean and everybody that have his designation starting with C, Chief Executive Officer, Chief Finance Officer, Chief Operating Officer, Chief Information Officer, right? Chief Security Officer, and all of those guys, you classify them as C-level executive officers. So always know that a pen tester typically uses various tools throughout the testing phases of the penetration report, right? So, and each of some of these tools, you can actually export your report. You can take screenshot. So it's a good thing to have. However, just because a tool has the capability does not mean you should export it to the findings and simply regurgitate those findings to your final report. So you just have to be very concise in, you know, that everything that comes out from your output verbose, you just like push everything out. No, they are almost always false positive or false negative in the result of any tool. That's why most of the times when you're doing vulnerability assessment, you want to use multiple tools or multiple scripts or multiple ways to actually confirm. So you don't just tell a client. It's like saying somebody is likely to have, sorry to use example, let's say heart attack. So, and you do a first test of, let's say, for a very grave illness or sickness. You don't just do the first test and say, the doctor says, okay, that is it. No, the doctor will likely say, please, can you conduct another test? So this is just so that you're very sure because of the grave importance or the grave nature of what is going to be the aftermath if it is positive. So you're going to have some results that are not actually correct. So you want to be double sure. Now, your report content should have executive summary, social have scope details, right? For students that are taking our internship or taking this training, we're going to examine samples of reports so that you see what an actual report is. So if you're interested in taking our cybersecurity and digital forensics, data engineering, cloud computing, project management trainings, or internship, you can speak to us and attend some of our free classes. We also have premium paid classes, and you can also take certifications with us. We are a Google, CompTIA, AWS, and Cisco accredited partners, right? So for students taking this course as in a group, we're going to examine some sample report. You can also Google and say pen testing sample report. You're going to see what it looks like. It's most likely going to have an executive summary. It's going to have scope details. It's also going to have some findings. So there should be something that tells you that, okay, this is what you found out. And most of the times, you don't just present your findings with your own words, kind of. You have to tie that to standards in terms of reporting. You want to tie that with industry accepted risk ratings. So some of them are CVSS, some of them are first. You have CVVSS is always very common because if you run a tool like Nexus, you run a tool like OWASP ZAP, when it brings out the result, it's going to tell you that, okay, this particular vulnerable, this is the score from 0 to 10. It's very dangerous. And this is the number for this particular vulnerability so that you can look it up, right? Most tools are going to give you a score. Now, you're also going to say what you did. You're going to tell us like how you did it so that we can, if it needs to be replicated, it can also happen. So a report should provide details on the methodology used to complete the testing. Did you do port scanning? Did you do social engineering? What did you do, right? So you want to explain those things in summary, kind of. Remediation. So you should provide clear guidance on how to mitigate and remediate each vulnerability. Then you have a conclusion, then an appendix. Appendix is going to have like images, screenshots, let's say something you were doing, what you found out, mostly screenshots, images, tables. You can have all of those things in an appendix. So we're trying to say that when you do a vulnerability assessment or a pen testing or a security audit, you should have executive summary, scope details, findings, methodology, remediations, conclusion, appendix. You can merge two of these together. You can expand this more. And the most important thing is that you want to communicate what actually happened in your test. One thing you should also note is that vulnerability scanners rely heavily on catalogs of known vulnerabilities. And that's why it's called common vulnerabilities and exploits. Common vulnerabilities and exploits, or common vulnerabilities and exposure. That's why it's called that. So because it's publicly known, and that's why it's going to have a score. So you can kind of do a test and you see something that is a vulnerability from your experience and you don't see a score for it. So it might just be an emerging threat. It might be something that is just coming up or something that has not already been documented. Right? I've found that sometimes when you do some tests or you do digital forensics, even aftermath of a hack, and you find some images, some text, some script, you want to check out and see if there is something like that elsewhere. At times you might not find that. So you need to be very also conscious of that. So metric groups used to determine the overall CVSS score of a vulnerability is the base metric group, the temporal metric group, and the environmental metric group. So you have these three categorizations. So for the base metric group, it just includes the metric. For example, what is the attack vector? What's the privilege? What privilege is required? Is it an admin privilege? Is it user privilege? What kind of interaction happens? Then what's the impact? Right? What's the impact of the attack? I think in one of the labs, we looked at common vulnerability exploits, about the 2-3 databases, and we saw some of these scores. So this also includes exploit code maturity. When you talk about maturity, you're going to say how known, for how many years. There are some exploits that have lasted for, let's say, for like 2, 3, 4 years, right? Whereas some exploits are just very new. Then, of course, you have environmental metric group, right? So this risk protection can help your customer understand the business impact of the vulnerability that you found during the penetration testing engagement. Most of the times, if you use any tool that brings out a result and it has a CV score or it has a CV number, it's going to provide all of these details, right? If you go to cve.org, you'll see most of the vulnerabilities and you'll see also their details. Now, storage time for reports and secure distribution. So there's one thing about having your report, then there's another thing about distributing it. So who should have it and how should you send it out? Should you send it out in soft copy? Should you send it out in hard copy? Who should have it? So some of these documents can be highly top secret. Imagine you found out some vulnerabilities in the CEO system or in the finance department or in some sections of the server. Who should know that? So understand that the report content should be classified and distributed on the need to know basis. Simply the principles of least privilege. You don't just send reports to anybody within the organization, right? So it should be, and some of these things you should kind of take care of them and have them planned out even before the test. So that somebody's not coming to meet you and say, okay, please, how far, what's up? Are you done with your test? What did you find out? All of those kind of stuff. So you don't want to be in such kind of situation. So before the job even gets approved, you want to set out a clear line of communication, right? So that most of these things are handled with care. Now, some examples of how to control the distribution of reports is that just produce only limited number of copies, define a distribution list in the scope of work. Distribution list is how many copies you're going to have and who will have them. So if you say 3 copies, one for the CEO, one for the technical department head, then one you're going to use for training that's going to be maybe in a secured system or something or whatever. So that's 3, you should define it so that nobody's going to come back to ask for an extra copy. If the person needs an extra copy, then scope will have to be adjusted because it now becomes a scope creep. So you need to label each with an ID. ID can just be VAPT01 CEO. Maybe that particular copy goes to the CEO, then VAPT head tech 01. So that goes to like that. So label each copy to the person's name and all of that. Then keep a log. So the idea of all of these distribution tactics and strategies is just to make sure that it's secured. The right person gets the information. So something like this. Copy 001 is going to go to the CEO. The name is this, and this is the date. Number 2 is going to go to the IRT team. That's the Cybersecurity Incident Response team. It's going to go to Gendo. It's going to go to that person. Then the person managing cloud is going to go to that person. So note taking. So it's a very common question when it comes to data collection and report writing. Exactly when should you start putting all the information together? I can tell you that from day one, from when you start running your test, you start gathering all of your information because that's what's going to now serve as your summary. Now, a report is the final outcome of the Pentest report. The most accurate and comprehensive way to compare report is to start collecting the result while you are still testing, right from the beginning. In other words, you need to understand the process of ongoing documentation during testing. As you come across findings, you document them. Take screenshots of the tools you use, the steps, and what it gave to you. That's how you can ultimately now say, okay, from what we did, this is the result. Now, don't forget to also look at themes and root cause analysis. So why did something happen? The only way you can get that is while you're actually documenting most of this stuff. If you find that, okay, on the particular port or you try to do something and so happens, you should document it, right? Documentation is actually going to help you even for you to do recommendations. Right, so in one of the labs, we're going to look at publicly available pen testing report standards. How do you develop your own report? I think we're going to be working on this in the labs. Then how do you create your own report? We're going to perform a simple pen testing report in the lab sessions for students in training. Then we're going to actually generate and create a simple report. Okay, the next thing is, how do you now analyze the findings you've gotten? How do you do recommendation to the right person? Now, during a pen testing engagement, you should analyze the findings and recommend the appropriate remediation within your report, including technical, administrative, operational, and physical control. Now, when you classify controls, that's to say, you want to classify the different ways to secure a system. You know, cybersecurity analyst, your job is just to make sure that you have secure system. And 3 or 4 ways you can classify those controls are technical controls. That is when you use softwares, servers, firewalls, applications, and all of that. That's technical control to make sure that a system is secured. Administrative, when you do things like job rotation, you say, okay, we want to make sure that people don't pilfer, people don't tamper with data, people don't do things the wrong way. So if you work here, after 2 weeks, after 3 months, you're going to change department, you're going to work here. That's an administrative control. That is job rotation. Or you're going to say, okay, we're going to have a procedure. We're going to have a guideline. We're going to have a principle, right? So this is how things should be done so that we can be secure. Then, of course, you have operational. How should things be done in terms of getting clients, serving the clients, deploying stuff to clients, and all of that. Then you have physical controls. That's where you have things like CCTV systems, access control, you have door locks, you have a server room that is that have a lock and key, you have maybe if it's for your for your server room, if it's a data center, what kind of fence do you have, kind of fire controls, all of those things that are actually physical that you make sure. Like I would normally say that if you have the best servers, the best technical controls, and if that place, people can just walk in and have access to it, you're not secured. So in your suggestions of remediation, you want to make sure to include all the different ways. Imagine you have a system that holds data for quite a lot of things within the enterprise. Now, 2, 3 people have access to that particular system. Maybe they have three different whatever, maybe access control or usernames and passwords. Now, because of the location of that particular system, it can lead to a vulnerability. It can lead to people maybe spying on what goes on there and the rest. So a good physical control is going to be that that particular room, nobody can enter there without swiping a card, and you just have to be those 3%. Right? That's an example of a physical control. You having things like badges, have swipe, maybe have a security system and all of that. So technical control is going to be things like hardening your system, make sure that you don't have insecure code, doing user input sanitization and query parameterization. This is going to help you prevent SQL injection and all of that. You can look at OAups to see some of those recommendations. Then process level remediation. So you want to make sure that the operating system handles things the right way. So the underlying system can always be manipulated. So if you don't code properly, if you don't implement things properly, most operating systems are not going to deploy things the right way. There you have MFA, you have password encryption, you have patch management. All of these things are classified as physical control. So what we're trying to say is that if you finish a security audit, a vulnerability assessment, what you should do is that at the end of the day, you should suggest some of these technical controls, right? Key rotation, certificate management, security management solution. You should suggest them. Network segmentations. You want to have VLANs. You want to have segmentation of networks so that you don't have one collision domain, right? Then administrative control. So for administrative control, in trying to suggest what best they should do, what you should do is that you should have role-based asset control. So people shouldn't just access things anyhow, right? Like I said, you could have control system that is based on roles, not necessarily users. So you can say maybe IT department, you have 2 persons in IT department, you create a role for access to a particular digital asset, and anybody that is in that particular department or in that particular have that particular role, the person can have access. If you're not in that particular role or department, you don't have access. Administrative control is also going to be having good software development life cycle. If you checked my channel on the web programming series, I think one of the very first video is software development life cycle. I laid down the entire principle of you actually setting up softwares to make sure that the project manager, the software developer, the business analyst, the UI UX designer, the security engineer, the cloud application developer, everybody is in sync. And software development lifecycle is just saying, okay, from start to finish, right from planning to design to development, quality assurance, launch, end to end, you want to make sure that it is secured. So if you don't have a good process or you don't implement OAups, that is all of those top 10 stuff that helps our application to be secured, then you're going to have an insecure software. The minimum password requirements. So you should have controls like saying, okay, you must have minimum of 10 characters. It must have these letters. It must have this. It must be alphanumeric and the rest. You must use a special character. Then policies and procedures are still part of administrative control. So for policies and procedures, you want to say how things should be done in the enterprise. People don't just do things the way they want to do it, right? There must be some guidelines. Then operational is going to be like job rotation. I think I mixed up job rotation as administrative. So operational, job rotation, time of day restriction, mandatory vacations, all of these things. And at times, some controls can be both operational and administrative, depending on how it has been deployed, right? Depending on how it is being deployed. Then, of course, training. Training is so crucial. You can't do quite a lot of things without training. Training is so crucial, so crucial, because training is going to help you. And the NIST, the US, one of the US standards, that is the National Institute of Standard and Technology, have quite a lot of documentation, quite a lot of guidelines on how things should be done. So you can Google and check out building an information technology security awareness and training program. That is report 800-50. You can look it up. It outlines how training can be done. So you also have physical control. So physical control is when you're done with your penetration testing, and at times your security audit or your vulnerability assessment or your pen testing, when you're trying to do these tests and checks, you're actually looking at to make sure that all of these things are there. So if they are not there, that should be what should be part of your remediation. It's as simple as that. So look at it that I want to do VAPT. I want to do security audit. I want to do VAPT. Now, my job is test the systems and see what is not there. Right? Test the system and see what is not there. Now, the question is, when you see what is not there, note it. When you see what is there, that's supposed to be there, note it. And in your recommendations, you now advise on what should be done that is not there. Right? So we have remediation, recommend remediation based on findings. So I think there's a lab here that talks about identifying and prioritizing vulnerability found on a down vulnerable web application. A down vulnerable web application is just a PHP, MySQL, or an Apache server-based application that is you can deploy on Linux, and it has quite a lot of vulnerabilities. So you just maybe use OWASP app or use any tool, test it. If you see the vulnerability, and you can document it. So we're going to do some of these things if you're enrolled in a training, or we're going to have a separate series for the lab sessions. Okay, the next thing is explaining the importance of communication. So communication is so important, right? You can't actually run all these tests without informing your client, without actually deploying, without actually testing, without actually telling people what's up. So critical, so important. If you don't do that, then you're going to have issues. So because certain situations may arise and you have to plan ahead, even before. You have to plan, you have to plan, you have to plan, you have to plan. Very important, you have to plan. Once you plan, it's very, very, it makes everything very good, because if you may encounter a scope creep situation if there's poor change management in a penetration testing engagement. What do you call scope creep? A client says, come and do testing for us. We have one website. While you're working on the project, they now tell you, okay, that this website is also part of another of our website. When visitors come to this website, they now get redirected to this particular website. So we also want to test the other website. That's the scope creep. Because the initial engagement says test one website, but later on you now find out they have 5 other websites. It's going to cost you more. It's going to need more manpower. It's going to take you more time. It's going to take you more resources. So you don't want that to happen. That's why the first thing you want to do is to do proper planning. You can check out module 1. I address that exhaustively. Then, even in your planning, how communication is to be done, you have to state it out, right? Poor communication among stakeholders. Even stakeholders, I've seen situations whereby even within the enterprise, they don't communicate with each other. I remember a particular task we were trying to work on one time, and this person is going to say, this is what we want. Another person is going to say, this is what we want. What we just do is that let us have a document. Let us document everything. Once we have everything properly documented, then everybody agrees on it. Then before we now start taking action on it. So that is the right way to do this stuff. So you should have a primary point of contact. You should have a technical contact. That is, if something technical goes wrong, then you should have an emergency contact. And the thing is that you might even be testing stuffs that are deployed by third party. let's say you have a server that is deployed by a third party. You have a cloud implementation that was deployed by a third party. You should have their contact. Because while testing, if that thing goes wrong, right, you should be able to inform them, right? Then critical findings, you should have that. Let's say while doing your testing, you see something that is so critical that you cannot wait till the end of the testing. You just have to communicate immediately. Then status report, you can have periodic report where you say, okay, we're going to be reporting every, let's say it's a 3 months testing or 2 months testing. That means we're going to report every 2 weeks, especially for very large scale testing. Okay, then also, of course, you have indicators of prior compromise. So you see something that is like a compromise that have happened even before you started your job. From what you're saying, you actually want to communicate immediately without waiting until you deliver the final report. Reasons why you should communicate: you should know the proper way to communicate, right? You should try to deconflict any potential redundant or irrelevant information from your report. You should try to identify and avoid false positive reports so that you don't raise false alarm. You should also report any criminal activity that you may have discovered, right? It's part of your job. Don't say you want to try to protect somebody, because if something goes wrong, they're going to say, okay, you were contacted, you were contracted, and these are part of the things you were supposed to help us identify, and you did not do it. Okay, I think that's basically all for that section. So we have post-report delivery activity. So what do you do after, right? So you want to clean up, you want to, let's say you run some tests, some of the applications you used, you want to delete them, some of the testing you did, some of the exports you did, you want to make sure that you clean up all of those things. You want to actually have things neat. If you deploy the staging environment, that's to say that you deployed, some application, it's live, but you cannot test live, or some network. You implemented something like a clone or something like that mimics what they have to not test it, so it doesn't affect the ongoing processes and the rest. You want to take off all of those things, restore systems and databases and applications and network in their original state, right? Okay, so there are some examples of items you want to be sure to clean. So tester created credentials. Let's say, please create me username and password so that I can test this particular system. You want to remove all and delete all of those things. Shells, remove shells found on exploited systems. You want to take all of those things down. Tools, did you install any tools on their systems? You want to remove that. Now, you are not done. Every cybersecurity project is not done until the client accepts it is done. Right? It is not done until the client accepts that it is done. So, lessons learned, follow-up actions, retest. So you can recommend and tell them, okay, you guys should be testing every 3 months, every 6 months, every 1 year, data destruction process. So all of these things are things you've done after your report. Okay, so these are some of the things we've learned. We've learned different audience, who is going to be in our report, the C-level executive, the technical guys, the content. We examined a simple report. What is the content? We looked at secure distribution to be sure that the right person gets it. We looked at note-taking, use of tools, root cause analysis. You should be looking at that. So, and the only best way to get that is right from the beginning of your report. The quality of your report, client will have to approve. Then some recommendation is going to be technical, administrative, then operational and physical controls, right? So communication is very key, right? You have to communicate. And I've done some things, you're going to find that you don't need to wait till the end of the report. You need to report and communicate immediately, right? So some triggers, things like indicators of compromise. You look at some critical findings you've seen. You don't need to wait. You just report immediately. So I think that's all for this module. See you guys in the next module. I think we have a few modules left and we're going to be done with the ethical hacker slide explainer series. Thank you very much. Don't forget to share, and you can send this to as many persons that you know interested in cybersecurity, in tech. We have about 20 playlist series of tech in project management, cloud computing, digital forensics, business analysis, quite a lot. So I'm taking my time to put up this series so that we can have a lot of time for hands-on practices for students that sign up for either our internship programs or our training programs. Thank you very much. See you in the next session. If you have a question, don't forget to use the comment section, and I would love to see your comments. Let me know if you're getting anything. Catch you.